Well, we're going to talk, I'm going to talk about how we prevented subdomain takeovers and saved lots of money and also made our infrastructure more secure as well. So yeah, what I'm going to cover today, firstly, I'm going to start by just giving you the basics of what subdomain takeover actually is, just to illustrate that and explain it. And then I'll talk about why it became an issue for OVO Energy, as this work has been done, for me while working for OVO Energy, and why we decided to develop our own open source tool to protect against subdomain takeovers. I'll then give a live demo and also then talk about some of the improvements that we've made and the results and what we believe the next steps are. So that's the plan. So let's get straight on to it. And I'm going to start with explaining fairly quickly what subdomain takeover actually is. And I'm going to take an example here because there are lots of different types. But for example, an engineer creates an S3 bucket in Amazon Web Services, AWS, and then creates a Route 53 DNS entry pointing to that S3 bucket. An end user then resolves that domain using the Route 53 DNS, and their web browser will then access that resource. So that's all fine, works fine. But then what happens maybe a couple of years later, maybe when that engineer's left and somebody else has taken over, and they decide to do a bit of cleaning up of that AWS account. They see this S3 bucket, decide it's not needed anymore, so they delete the S3 bucket. But what they might not do, they might forget or not realize that they also need to remove the DNS entry that's pointing to it. So that is sometimes referred to as a dangling DNS entry and is a problem because an attacker or bug bounty researcher can create their own S3 bucket with exactly the same the name and in the same region. And then at that point, the attacker has control over that domain. And that can be a serious issue because the attacker can use that domain, which can look extremely convincing, to create very realistic phishing attacks. They might harvest credentials from customers. They might use that to install malware on end user devices. So it is a serious problem. And this is just one example with the S3 bucket. There are lots of different types of examples of different sorts of cloud resources across AWS, GCP, Azure, and other clouds that are susceptible to this type of takeover. So at this point, I'm just going to create some deliberately vulnerable domains. So here I have my Route 53 service within one of my AWS accounts within my own AWS organization. I'm going to go into hosted zones. So you'll see here, I have a hosted zone called Celidor.io, and that's because I've registered that domain, Celidor.io. And I've also created a subdomain called Pluto.celidor.io. I don't know why I said Pluto, I just fancied planets for this demonstration. So I've created a subdomain called Pluto.celidor.io. And if I select this, you'll see that this has 4 name servers that are assigned by Amazon. And that's all absolutely fine. But for that to actually work, we need to delegate that subdomain from the parent domain. And in this particular case, it's in the same AWS account, but it doesn't necessarily have to be. So if I go into this parent domain, you can see here, I've got lots of different DNS entries. And I've got one here called Pluto.celidor.io. And this points to the 4 DNS servers, which are in that delegated hosted zone. So that all works absolutely fine. But what happens when somebody decides, well, actually, we need to reduce costs a bit. And these hosted zones are costing me $1 or $1.50 a month or whatever it is. So we don't need that one anymore. So actually, we're going to delete it. So we're just going to select that one and we delete that hosted zone. So I'll just confirm that I do want to delete that hosted zone. So now I've deleted it. So now we've got a bit of a problem because we've forgotten or didn't realize we also needed to remove that delegated name server entry in Celidor.io. So potentially an attacker could, through a brute force type of attack, take over the name servers and then have complete control of that subdomain. And if they do that, they could use it to issue SSL certificates, create virtual machines, do really anything they want, and it would be extremely realistic. So that's one example. So let's just go ahead and create a few more deliberately vulnerable domains. So I'm going to go back into my hosted zone, Celidor.io, and now I'm going to create a record for an S3, a CNAME to an S3 bucket. So I'm going to call this one Mercury.Celidor.io, and the I'm going to point this to an S3 bucket. So I'm going to create that record. So obviously you wouldn't really do it quite like this. Really, you'll create the S3 bucket first, and then create the DNS record, and then you'd maybe a year or two later, you might delete that S3 bucket. But I'm simulating that by just going straight to the end state. So I've created that S3 record that is also potentially vulnerable. So now I'm going to create another one. So let's now create an A record. So this is going to be sticking with the planet theme. I'm going to call this one Jupiter.Celidor.io. And in this case, this is going to go to an IP address. And this is an IP address that is an Amazon Web Services IP address, but it's not one within my organization. So this is sort of simulating a record that points to an IP address and that is no longer in use and could again potentially be taken over by an attacker or bug bounty researcher. And now I'm also going to go to, I'm now going to go to Cloudflare. And within Cloudflare, Cloudflare has a whole load of different services, including secure proxy servers, security services, and it has the ability to manage DNS as well. So I'm just going to create a record. You'll see here I've delegated this particular domain to Cloudflare, and I'm going to add a record here. So I'm going to pick a CNAME here, and I'm going to call this one More Planets. So this is going to be Neptune. If I keep doing too many, I'll run out of planets, but don't worry, I won't be doing that. And this one is going to point to an Elastic Beanstalk instance. And this is, we don't want to have proxy set for this, and I'm going to save that. So I've now created 4 different vulnerable DNS records. This last one is simulating a CNAME pointing to an Elastic Beanstalk environment where somebody gone ahead and removed that and deleted that Elastic Beanstalk environment in AWS without realizing or remembering to remove the Route 53, the Cloudflare record that points to it. So let's return now to the presentation now that we've created those vulnerable domains. I'll come back to those. So why was all this important to us at OVO Energy? Around a year ago, we decided to initiate our first bug bounty program. And we found this to have been a very fruitful and productive program. As you can see, we've paid quite a bit of money and we've had quite a lot of findings, and it's been a very active program. And you'll also see that it's gradually increased. So you might be wondering why that is, and then it decreases. Well, the explanation is quite simple. So the first quarter wasn't a complete quarter. That was just about a month. The second quarter was starting to get going, but with an initial rather limited scope. And then we dramatically increased the scope to cover all our major brands. And that was in the third quarter of last year. So that really explains the increase in scope. And then since then, we haven't had any further scope increases. We'd like to think we're getting a bit more mature at security, and perhaps the bug bounty researchers have found a lot of the low-hanging fruit. So we are still getting findings, but at a lower level. And what's significant is that within the first 3 to 6 months of this program running, about half, so that's 50% of the findings and also the monetary rewards were all around subdomain takeover. So this highlighted the fact that it was an issue for our organization, and we realized that we needed to do something about it, not just to save money, but to improve the security of our infrastructure and applications. So we had a look around at what tools could we use to help us achieve this. And we really didn't find very much at all that was available. We didn't really find commercial tools. We didn't find open source tools. The only things we really found were some open source scripts and some open source tools, which were really more aimed at ethical hackers and bug bounty researchers, but weren't aimed at defending an environment and applications. So we decided that we were going to write our own, and we did. So that then led to the open source tool Domain Protect. And you'll find this open source repository at github.com/overtech/domain-protect. And all the links on this page I've put into the hallway-Paul-Schwarzenberger Slack channel within the SANS Slack workspace. So you can find all the links there. The Domain Protect, this Domain Protect repo is for Amazon Web Services and Cloudflare. We also later developed another application and system, Domain Protect GCP, and both of those we open sourced. There are also 2 tech blogs that you can read if you want to see more information. And again, the links for these are in the hallway-Paul-Schwarzenberger Slack channel within the SANS workspace. So that's Domain Protect. So what does it actually do? Well, it's a collection, it's a completely serverless solution, and it's a collection of different serverless services such as Lambda, Dynamodb, step functions, SNS topics, etc. And it's designed to run in an AWS organization. Now, we talked quite a lot about AWS organizations, and in the initial discussion this morning, in the first session, I enjoyed hearing from Kat and Frank and Eric about what an AWS organization should look like with the management account, and the security OU and the workload OUs and so on. So you all know what an AWS organization looks like, or what it should look like. So not all of us look quite as neat as that. But anyway, nearly all organizations hopefully have at the very least a security account. And that's where this you would normally implement Domain Protect. So there's a Lambda serverless function within the security audit account. And the first thing that does is to assume a role into the organization management account. And then in that organization management account, it then lists all the accounts in the organization. So far, so good. What that Lambda function then does is it triggers a step function. And the step function in turn triggers a separate Lambda function for every single AWS account in that organization and runs them all in parallel. So that can be hundreds of AWS accounts. It could even be thousands of AWS accounts in the bigger organizations. Each of those Lambda functions assumes a role to their target account. And then once in that target account, it goes through all of the Route 53 hosted zones, and it looks at all the different entries in those hosted zones. And then it does tests to determine whether those entries might be vulnerable. And those tests are a mixture of DNS checks and some web request checks. So once it's done all of those scans, it then writes the results of any vulnerable domains to the DynamoDB table for vulnerabilities. It also publishes any new findings to an SNS topic. A Lambda function, another separate Lambda function, subscribes to that SNS topic and then sends the results to the Slack channels which have been specified. As well as that, you can directly subscribe an email address to that SNS topic and receive alerts by email in JSON format. So that's how Domain Protect works. There are a few other Lambda functions as well, which I've kept out of this for simplification, doing regular reports and so on. But this is the fundamentals. So that's how Domain Protect works. Here's some example alerts. I'll show you some of this live as well. So this is the sort of a Slack alert which you would get if a new vulnerable domain is discovered. You may notice that in this particular case, we have enabled BugCrowd integration, and we've actually created an issue within BugCrowd, bug bounty platform, using the BugCrowd API. This is another type of alert that you receive once a vulnerable domain has been fixed or taken over. We also receive a daily report of all of the domains currently vulnerable to takeover. Hopefully you wouldn't actually have that many unfixed vulnerabilities in your environment, but this is for illustration. And maybe you probably would get this when you first turn it on. There's also the option to manually scan from your laptop. So this is more useful for initially, if you just want to have a play around, you can get some results by doing this. However, this is just within a single AWS account at one time. It won't scan the entire AWS organization. And of course, it is just a point in time. So you could scan an account and it could look fine. And then 5 minutes later, some engineer could do something which creates a vulnerability. So, I'd really recommend going for the full implementation with the serverless infrastructure. So the vulnerability types which are supported are, firstly, we look at AWS Amazon Route 53 DNS. We look at Cloudflare DNS. We can look at Google Cloud DNS, and we can look for vulnerable resource types across Amazon Web Services, Cloudflare, Google Cloud Platform, and also Microsoft Azure. The supported vulnerability types in AWS are registered domains. So that's where you actually register a domain in AWS in the same way that you would with GoDaddy or someone like that. The NS records for delegating subdomains, as I illustrated earlier. Alias and canonical name or CNAME records pointing to elastic beanstalk environments and S3 buckets. Alias and CNAME records pointing to CloudFront distributions with a missing S3 origin. So that's where somebody's deleted an S3 origin for CloudFront, but has left the CloudFront infrastructure in place and the DNS record. It has happened. CNAME to Azure, a whole variety of different Azure and Google Cloud resources. And brand new, I'm very pleased to announce that we now also support A records pointing to IPv4 addresses, and in particular, public IP addresses of EC2 instances, elastic IPs, and global accelerator IP addresses. And so what we're looking for in this test is we're looking for A records that are pointed to IP addresses that maybe one day were in use by the organization, but are no longer in use. And so an attacker could take those over. So that's what we did. And that all hopefully sounds wonderful, but it didn't work out quite as smoothly as we might have thought. So to start off with, Domain Protect ran once per day. And we had a manual approach of informing teams that they needed to fix things. And sometimes that took a few days. And that cost money, because what we found was that subdomains were taken over by bug bounty researchers before the vulnerability was fixed. And in some cases, even before Domain Protect identified the issue. So we needed to do something about it. And of course, it's not just bug bounty researchers and the financial aspects, but more importantly, there's a genuine risk from malicious attackers. So we introduced automated takeover within the security account. And as part of that, up the frequency of the scans dramatically. So the idea of this is that we do a friendly takeover, as it were. So we actually take over certain types of resources ourselves before the attackers or bug bounty researchers could do so. And this is just a screenshot of an example. And the types of takeover which we support in this way are elastic beanstalk environments and S3 buckets. And this automated takeover within the security account is optional. So if you don't want to, or if you're a bit nervous about trying this straight away, you can turn this off. Quite a lot of the features within Domain Protect are optional and can be turned on and off. It's all deployed using Terraform, and you can just change different variables to turn on or turn off certain features. So, that's a summary of Domain Protect. So what I'm going to do now is let's see what's actually happened since I created those 4 vulnerable domains at the beginning of the session. So let's have a look at Slack. So here we are. We've got some new messages. So so just before, hopefully you can all see that. I'll just make that slightly larger. So yes, just before we started, early this afternoon, I actually fixed a vulnerable domain. So that accounts for this. That was before we started. And then you'll see all the messages that say new are the ones that have happened live while we've been talking, or while I've been talking. So it has identified a number of different vulnerable domains. So it identified the elastic beanstalk resource. It says that that has then been fixed. We'll have a look at that in a minute. It also says that an S3 bucket was successfully created to protect this domain, mercury.celidor.io. It says that the A record has been identified as vulnerable, jupiter.celidor.io. So we're going through the planets now. It's identified the Pluto.celidor.io. That's the delegated subdomain. And you can see that's been fixed. And these are the and also the elastic beanstalk instance has been created. So let's have a look at some of those. So firstly, if we just click on this link, let's see what happens. Okay, so that's the S3 bucket that was created automatically by Domain Protect while I've been talking. Now let's just do the same, going to the elastic beanstalk instance. Okay, so there we are. So we've got an elastic beanstalk instance created automatically by Domain Protect, as well as the S3 bucket. So that's all good stuff. So let's have a look at some of that actually within the security account. So here I am in the AWS console, and this time, instead of logging into the account where I had the Route 53 records, I've logged into the account where, the security audit account, where I have the Lambda functions. And you can see here, I have step functions for both the IP address scanned for A record check and the scan for all the other records. So if I select this step function, you can see it's been running regularly, and I can select the latest one of these. And here are the Lambda functions, which are running for all the different AWS accounts in my organization. There's about 5 or 6 of them. So that's that shows that everything's sort of running smoothly. There's no errors shown there. If I now go to the Dynamodb database, so this is the actual database where all the vulnerabilities since the beginning of time for this environment have been recorded. So we've got lots of, I've been doing lots of testing, so there are lots of different vulnerabilities, as you can imagine. And the vulnerabilities has the found, the date and time that the vulnerability is found, and also the date that it's been fixed. And this is the Dynamodb table is really important because it then provides enables a lot of the functionality that we want to do in terms of new alerts and when something's fixed and so on. So it provides all of the logic effectively, or enables the logic of knowing so that the stateless applications can determine whether vulnerability has been identified already or not. So that's the Dynamodb table. The other thing that we can do, if I just go back to the Slack channel and then just go back to the to here. The other thing that happens once every 24 hours is we have as I mentioned, we have a function that that runs, which just simply provides a report of everything that's vulnerable at the moment. So rather than wait 24 hours, I could just do that as a test. And if I go back to the Slack channel, you'll see here, we now have a list of the domains which are currently vulnerable to takeover. So here we are. There's a registered domain which is there already. It wasn't part of the demo. And we've also got the A record, which is vulnerable, and the name server record, which is vulnerable. The two items which have been, the two domains which have had the friendly takeover are not listed in this. However, there's another report that lists those, and again, that runs every 24 hours as well. So that illustrates domain protect in action, and I'm amazed and pleased that all works. You never know with live demos, but that works. So that was good. Just returning to the presentation now. So what were the results for OVO Energy after implementing? So the results till the end of March, and I just hadn't, as it happened, I hadn't updated it since then, but there haven't been very many since March. So this is sort of around about a year. This has been the first year. So the total number of vulnerable domains was just over 200. And about half of these have been identified by Domain Protect in AWS. Around a quarter in red by manual scans, and that was mainly at the beginning before we developed Domain Protect. We did a few manual scans. And then the blue segment is the bug bounty program, and the purple segment is Domain Protect GCP. So that's a summary of the results, which has been so we found that the whole exercise of implementing Domain Protect and developing it has been very productive and fruitful for us in identifying vulnerable domains and now in keeping them under control. And what I would also say actually is that in the process of doing all this, our DevOps and developers have become much more, their understanding of why this is important has increased massively. So yeah, there's a much stronger awareness of the importance of subdomain takeover and what they need to do to make sure that that doesn't happen, because in our case we have a lot of fairly autonomous teams across the organization. So they're the results. So what's next? Well, I guess firstly, before we perhaps go on to what's next, I would also like to thank so it's quite a lot. Well, I thank those people who have installed Domain Protect in their organizations using the open source repo, who have then fed back to me how useful it's been to them. And what I would say is, a lot of organizations out there are using Domain Protect, and have in some cases found substantial numbers of vulnerabilities, and are now working their way through improving them, and they have found it useful. So that's good. And I would really just sort of encourage anybody who does use it, if you can, if you do want to, you obviously don't have to, but if you want to let me know how you've got on, I'll keep anything you say in confidence, but I would be interested, so yeah, so it is in widespread use. So I hope a lot of you watching this, will also, consider implementing it in your own organization if you haven't already. So that being said, there are some possible enhancements. There always are with any new service. So we had a request yesterday via Twitter for an A record or IP address check, similar to that in AWS, but for the GCP version. Another possible enhancement that we're potentially interested in is extending it to Azure. And really, I'd be interested in anything that any of you have as suggestions, particularly those of you who have actually tried it or implemented it within your own organization. What do you actually want to see? That would be great to find out. And yeah, finally, external collaborators are welcome. If you would like to collaborate or put in a pull request, just contact me, and we can discuss the issue, and I can get you added as a with the permissions to to contribute to the open source repos. That'd be great. So with that, just like to say thank you very much, and contact details. So feel free to contact me